lot about probability in class, and now I'm just going to quickly go through some examples just to help you study. So you should read example 1. Like I said, I think you guys should use this more as like a checking. Like you should be able to do these problems at this point, and then kind of check your answer, but I'm going to walk through each solution if you need it. So looking at the first example, it says, on one shelf at the bowling alley, there are 5 black and 3 green bowling balls. One customer selects one at random, puts it back. The second customer selects a ball on the same shelf. What's the probability each customer picked a green bowling ball? So first customer picking a green bowling ball would be 3 is success because there are 3 green balls out of 8 total. And then, like we talked about, since we want another event to happen, this is like an and probability. Since the ball was returned, there are still 8 balls, still 3 of them on the shelf for the second person to pick from. So then our final answer would be 9 out of 64. Okay. So if they're replaced, we get 9 out of 64. Now, number 2 should say refer to example 1. Sorry. So now it's like the same scenario, but the ball is not put back on the shelf. So the first person still starts the scenario, so it's still 3/8. However, the next person, there's now only 7 balls on the shelf, and since one of the green ones has been removed, there's only 2 green ones. So this gives us 6 out of 56, or 3 out of 28. Okay. All right. Mark has 2 quarters. He needs 50 cents more to pay the toll booth. There are 4 dimes, 8 quarters, and 9 nickels. So we just 4 dimes, 8 quarters, 9 nickels, and this makes a total of 21 coins. All right. So he's picking without replacing the first one. So how's he going to get 1 quarter and then 1 nickel? So to get a quarter would be 8 out of the 21 coins that are in there. Now there would only be 20 coins, and then to get a nickel would be 9 out of 20. Okay? And then we could go ahead and simplify this. If you want to simplify ahead of time, like you're like, oh, 4 goes into 8 twice and into 25 times, and 3 goes into 21 7 times and into 9 3 times, it might make reducing your answer a little bit simpler. All right, then to get 2 quarters, it would start out the same. It would be 8 out of 21. But now, not only would there be 20 coins, but one of the quarters would be gone, so it would be 7 out of 20. Okay? And again, I'm going to reduce before I look at my final answer. So this is like 2 and 5, like 3 and 1. And so this is going to give me 2 out of 15. Okay. All right, so from a deck of 52 cards, 3 cards are randomly chosen. There are 10, a jack, and another 10 in that order. Find the probability if the cards are replaced. So if they are replaced, to get a 10 would be 4 out of 52 times a jack. No jacks have been taken out, so 4, and the cards are replaced here, so they're all in there every time, out of 52. And then another 10, still 4 out of 52. Okay? So each of these reduces to 1 out of 13. Okay? And so then we just have to know what 13 cubed is for our denominator, which is 2,197. So this is 1 out of 2,197. Now, if the cards are not replaced, we have 4 out of 52 for our 10 times. 4 jacks are still in there, but only 51 cards. And then now there's only 50 cards, and one of the 10s has been removed, so 3. Again, I'm going to try and reduce a little bit. Help me out here. 13. 3 goes into 51 17 times. And 4 and 50 are both divisible by 2. To make my life a little bit easier. So I have 2 out of whatever I get when I multiply 13 times 17 times 25. is 5,525. All right, example 5 says find the probability of drawing a jack or a queen from a standard deck of cards. So this is an or problem. I can get a jack or a queen, and those don't overlap at all. You can't be a jack and a queen at the same time in one single card. So getting a jack is 4 out of 52. Getting a queen is 4 out of 52. I want a common denominator, but these both reduce the same. So I'm going to get 2 out of 13. What is the probability of drawing a queen or a diamond from the deck of cards? So this is still an OR problem. So the probability of getting a queen, just like last time, is 4 out of 52. A diamond is 13 out of 52. However, there are queens that are also diamonds. There is one queen that is also a diamond out of 52 cards in a deck. Okay? So then here, I'm going to get 16 out of 52. Both of those are divisible by 4, so it's 4 out of 13. All right, Jerome has 5 quarters, 4 dimes, and 6 nickels in his pocket. He takes one coin from his pocket at random. What is the probability that it is a quarter or a nickel? Okay, so again, this is OR. So I'm successful with a quarter or a nickel. So there are 5 quarters out of the 15 coins in his pocket, or 6 nickels out of the 15, which means the probability I'm successful is 11 out of 15. Right. A survey of 300 people was conducted to determine how many people would participate in a recycling program. Of the people surveyed, 134 said they would recycle aluminum. 108 said they would recycle glass. Of those people, 62 said they would recycle both. If one person was selected at random, what's the probability that he or she would recycle aluminum or glass? So Venn diagram will help us with this because of the overlapping portion. So I'm going to call this aluminum and this glass. Okay. And then outside of the circles will be the people who don't want to recycle. So 62 people said they would recycle aluminum and glass. Okay. 134 said they would recycle aluminum, but that includes the 62 that said they would do both. So that leaves 72 people that will just do aluminum. 108 people said they would recycle glass, but again, that includes the 62 people. So that's 46 people would just recycle glass. Okay? And that is here a total of, if we add up the 72 plus 62 plus 46, we get 180. But 300 people were surveyed, and so that means 120 people aren't recycling anything. All right, so the question is, what is the probability that he or she would recycle aluminum or glass? So we want to include the people that would recycle aluminum plus the people that would recycle glass plus the people that would recycle both. So aluminum is 72 out of the 300. Glass is 46 out of the 300, and both is 62 out of the 300, okay, which we already said adds up to 180 out of 300, which nicely reduces to 6 out of 10, 3, this. Okay. All right, there are 5 boys and 6 girls on the yearbook staff. A committee of 5 people is being selected at random to design the front cover of the book. What is the probability that the committee will have at least 3 boys? Okay, so first of all, we talked about the word at least 3 boys, and we're choosing a committee up to 5 people. So we want to know 3 boys, that's a success for us. 4 boys, or 5 boys. Remember, that word at least, you need to understand, means these 3 different probabilities are all good and successful in our book right now. So the probability that 3 boys would be selected, since we're choosing a group, I'm going to use combinations here. And for our combinations, there are 11 people, and we're choosing a group of 5, okay? But our success in this case is 3 boys. So there are 5 boys. I want to choose 3 of them, and then we can't forget that the other 2 spots in our committee then would be filled with girls. Okay? Then the denominator won't change. There's still 11 people that we're choosing a committee of 5 from each time in total. The parameters are just changing. So for 4 boys, that means 4 are selected from the 5 boys. And then that means that 1 more committee member must be selected from the 6 girls. Finally, okay, to select 5 boys would fill our entire committee, so we don't need to worry about the girls. And those are being selected from 5 boys as well. Okay? So then we would go ahead and calculate this answer. So 11 choose 5 gives us 462. And I'm going to calculate each of the others. So 5 choose 3 times 6 choose 2. So when I calculate each one and then add them all together, I get 181 out of 462. All right. So hopefully you were able to do those examples after the hard ones that we were tackling in class. Then your quiz will contain counting problems and probability problems spanning sections 11.1 to 11.3. And after your quiz tomorrow, we'll work on homework 4. But if you want to do that now to study for your quiz, you can do that as well.